find evidence to say that the number of fish caught at the lakes is not uniformly distributed. Yes?
How did you get 8.6 already? How did you get 8.6 already?
Oh, just adding up these, did you get these values?
Yeah.
Just add them up. So you could.
Oh wait, no, I didn't get those.
Oh shit. Now how about these?
No.
Do you have these in
I
there?
got the first two.
Alright, so then L3 is going to be observed L1 minus expected L2 squared. So L3 is going to be L1 minus L2 squared, just like that. Observed minus expected squared. If you don't like the double negative, we have not found evidence to reject that they are uniformly distributed. You can say it like that. We have not found evidence to reject that they are uniformly. Which is another way of saying we have not found evidence to be able to say that they're not uniformly distributed. It's not a double negative. English is a little too strict on that. And we're a math class. We're all good with the double negatives, but it's not even what it is. Yes?
How come we did 79 divided by 9
Where are we at? Sorry? What's up? Sorry?
When you did 79 divided by 9, how come we didn't do like 11 out of...
I'm not, there's no probabilities here. That doesn't make any sense for this problem. There's no percentages. I actually could, to be honest, I could make this percentages observed and percentages expected, but that's, no, we're not going to do that. So I'm doing number observed, number expected. This step is just distributing evenly all the fish that were caught. We caught 79 fish divided by 9 lakes. That's what I would expect to happen if they were uniformly distributed. Yes? It doesn't do... Do it. Oh, I see. So you are trying to fit the entire list. But then you look at these problems. Oh, yeah. You're going to square it, it's just L2 is square all.
Yeah, it's expected for the whole LC. So because we add these all up, right? You have some okay, and then you want to make sure all of this is the same.
Alright, I understand that.
Then you do L1 minus L2 squared. No, and then like,
Go to, oh, wait a minute. Okay, alright, you ready? It's not before calculator's fault. Look. So whenever it says 10 mismatch points, what I should have went to, this means the dimensions of your list don't match. Meaning one has a missed spot. Alright. So, on the practice final, the very last problem is one of these. Number 6 and number 10 are hypothesis tests. I was really evil on this and didn't give you the 5 steps, but it's the same 5 steps for hypothesis tests for me. And just to remind you guys, when you're doing chapter 9 homework, section 9.5, don't use the worksheet in the back of the book that they ask you to reference. Use the 5 steps. They do something in technology, everything's kind of like backwards because they figure out the answer first and then they go. That's always neat. So we'll do them the right way. It's a free book, you gotta give them a little leeway, I guess. Yes?
How did you find this on the L4?
Oh, so there were two ways. The most direct way to do it, if you're in your list, you want to get out of it. So hit second mode to quit. Then you go to list, because I want to do something with my list. Second stat to go to list. I want to do math on a list. I want to sum a list. And then you just tell it L4. Cool. But I love this idea. Now look, real quick. The chi-square stuff, the goodness of fit, it's so beautiful. 0 means no difference observed. So that's definitely not good enough evidence. So not only do you have to not be 0, but you have to be so far away from 0. How far away? Well, that's this step. What's the benchmark I've got to get to, right? So that depends on what your alpha is and what your degrees of freedom are and all that kind of stuff, just like it did with T-scores. Maybe. So 0 means no difference. A little bit away from 0 might mean random variations that could acceptably happen. So you got to be so far away from 0 to really be evidence from just the sample that there is something different. So if I take any group of people across the United States, would their cholesterol exactly match the predicted distribution? No. But when is it evidence that something is different about them? That would be this test. I have to figure out how far away it's got to be based on my number of categories I'm looking at and so forth. You guys semi with me here?
So this is more just like saying like, it's kind of really, really broad. Like there's a difference or there's no difference.
Yeah, evidence of a difference.
Or
You got to be
evidence
careful
of a
because the reason we say that is just because a test doesn't find evidence that there's a difference doesn't say a damn thing about whether there is or not.
Right.
Same way if I say somebody there's evidence you're guilty, it doesn't mean you actually did it. There's just enough evidence, we're going to kill you, too bad. Sorry. It's true. It is true. You killed somebody. We can't let that happen, so we're going to kill him. Sorry. I'm going to try to keep my ideology out. Yes?
Because there was a percentage, how do we calculate the E?
Just like we did, so if there's a category that we expect 40% to be in, and there's 500 people, I just do 40% of 500. So 0.4 times 500. Because of means multiply. We all know this now for sure. Just like that last problem on the practice final. They give you percentages. So look at that last problem on the practice final. What percentage, what do I expect A's? How many A's do I expect? Well, I expect 13% of 342. So that's what goes here. You guys see that? How many do I expect? How many A's do I expect? I expect 13% A's, and I got 342 people, so I do 13% times 342, 0.13 times 342. And then I keep going. What is that? Does anybody see what that looks like? What kind of distribution this looks like? Those are the accepted percentages for 5 categories if it's supposed to follow a normal curve. So really my claim is it follows a normal curve. Most grade distributions don't quite follow a normal curve. Okay. So anything else you want to look at right now? Or if I'm you, I'm going to focus on homework primarily. There will be time tomorrow. I'm going to kind of like let you guys do certain of these in class tomorrow, and then I'll eventually give you the answer key tomorrow. Right? So it's not imperative that you do this. Homework is a little more important, believe it or not. And you know, even that statement, you can disagree with it and do whatever. So what I'm saying is, it's up to you. If you want to do a little more today, we can look at some more problems. or we can hold off until tomorrow. And the first thing we'll do actually is look at the quiz, right? Correct the quiz if we need to. If you need to. Some of you guys like, yeah. You guys can't handle like a open-ended. Tell me, you could get up and walk out if you are done with today. That's fine. Or you can ask a specific question about something. Yes.
Section 5.2, 74.
Yes. This here, right?
Yeah.
Okay. This is a really good question because a lot of people had trouble with this. Okay. Cool. Over there. Thank you. Okay. So guys, the one thing that people just skip with this problem is when I draw this rectangle. Why am I drawing a rectangle?
Because it's one over it's uniformly distributed.
If I say normal, bam. If I say uniform, rectangle, right? If I say chi-square, Jabba the Hutt. What's that rectangle going from to? 1 to 53. Yes? Now A is just asking what's the random variable? Follow. What does it follow? Follows a uniform distribution. Yeah, be uniform from 1 to 53. Yeah, it's that little thing where it's X is like binomial or normal, so it could be B and U. Graph it, so that's making the rectangle, and you have to figure out the height. What's the height going to be? 1 over. 1 over 52. No, not 1 more than 52. 1 over 52. Reciprocate 52. Right? The whole area. So the whole area of the rectangle has to be what? No matter what, the rectangle's area, the complete rectangle's area has to be what? What's the area, what's the total area under a normal curve? You guys, if this is 0.10, what's this? Okay, then you know. What's the total area under a normal curve? 1. You use that fact just now. And then you can't, and then you're like, wait a minute, what's the... So the total area of a visualization of a probability distribution must be 1 in order for it to be useful. So if this is from 1 to 53, so that's 52 across. What do I multiply 52 by to get 1? Well, you know this. It's the reciprocal of that width, so that it comes out to be 1 at the end. Now the book, I don't know if any of you guys have realized this. I don't really make a big deal on this. But when they say this, this is this. So that's 1 out of 52. That's basically another way to reference the height. D and E are just plug and chug shit, right? You know what A is, you know what B is, you can plug into the formulas for D and E. Is that alright? True? Yes, this is true. You don't need to know that stuff for part F. Find the probability a person is born the exact moment week 19 starts. So it doesn't say find the probability that they're born between this and this or something. So what is the area of that line? So this is probably x equals 19. That's basically 0. Right?
So it's 0 or 19?
Say again?
Is it 0 or 19?
It couldn't be 19 because that's bigger than 1. Well, and why are those the only two options? I don't understand. So this kind of question is definitely going to have an answer. An answer where you 0.7046 or something. Because it's got a width, doesn't it? It's the uniform probability. The answer will only not be 0 if I have an actual width. Because what's the answer always? The area of what I'm talking about. So if I want the probability x equals 19, what's the area of this line? What's the area of a line? What's the width of that line? It goes all the way from 19 to 19. 0. So the area is going to be 0, so the probability is 0. I talked a little bit about that. There's really this weird thing called iota and blah, 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 but that's like 0.0, an infinite number of zeros and then a 1. That's what iota is, which most of us would just call frickin' 0. So G should be not as bad. I want to go from 2 to 31. So just got to find the area of that rectangle, right? So let uniform probabilities be relatively simple. Right? They're just finding areas of rectangles. How wide is this guy? 29. Sorry, I didn't hear you. So what's the area of that rectangle? The width times the height. How tall is it? Whatever 52. So just 29 divided by 52, whatever the shit that is. Anyway, that's it. Keep going.
So in the book, it says that when p x equals like whatever number equals 0, it says that it's inconclusive when it equals that in the book.
Inconclusive. What do you mean?
Like when you look up for like the chapter 5.2, like it says like because you know it like does like the notes and stuff. It says that when you get that like it's 0 because it's inconclusive.
Show me where it says that. In the answers, or you mean in the chapter somewhere? Okay. Great. Let's see if there's any numbers. Maybe different. No, this is the same book as everybody. They don't have the special teacher's edition. Oh, inclusive? Inclusive?
Okay, I
Oh,
did
just,
that.
yeah, just including. Inclusive, yeah. No. Alright. So it's like instead of excluding, it's including the inputs.
Okay, because like I read that on my test and I was super confused.
I got you.
Sorry.
Yeah, they will sometimes use an equal sign here, we know that.
Okay,
So it's just another example of where they made some typos. Oh, so you thought it was the other way. I see. So which one is that? Yeah, fewer than 5%. Fewer than 5%. just means do you include the endpoint or not? That's all it means.
But like whenever it equals that, it's going to be zero.
True. It has nothing to do with the word inclusive. Nothing.
Okay, well,
Nothing. So inclusive just means, in this case, including 0.5 and 4. Exclusive would mean just the inside, right? It's like the difference between brackets or parentheses. Include or exclusive. So it's 0 because there's no area to it.
no.
Yeah, yeah. I was like, I didn't know it. I'm like, why?
Because I remember seeing it in the book and I was like,
But it doesn't, see, this is not a problem where it would be 0. And this got the word inclusive, because they're including the 0.5 and the 4.
So there was something else where it was just like,
It might be,
where it was 0, and that's what it
but that,
was.
see, no.
Oh, my brain's too funny.
If you find it, show it to me, because it's their mistake.
So I remember that you said you need to look up the z-score, like you did that, and then you look at the z-score.
Yes,
That's what I did.
I got like sent to the.
but this, okay, great, but what's the question actually asking? Oh, this is from the test, okay.
I wanna see what I got on, so I can make sure. You set that up in chart.
Yeah, negative 0.7, so what'd you say you got? Sure.
You did that.
Yeah, you don't get that. There's no way you get that, because 0 is 50%, and negative 0.7 is a little bit below 0. Two in the charts.
No, I found it.
Okay, good. Because I gave them all mine away. Negative 0.7. 0.
No, it's yours on the wrong side. What? I don't
See,
know.
I have no idea where they came
I don't
from.
know what
I think you did this. Let me see if I'm right. Yes, it's exactly what you did. You try to find 0.70 in here.
Oh, yeah.
This is
I
a
did.
z-score. Z-scores live out here. Yeah, that's what happened. Okay. And even then, I think you made the mistake again later. It's not 0.502. Do you see how, even if this was the right thing to do, then you would say 0.5, not 0.502. See how that's the second decimal place?
Okay.
So 0.52.
Okay.
Yeah. So it's like you add those together, basically. 0.5 plus 0.02 is 0.52.
Okay.
Yeah, not 0.502.
What did you wrong? Person, because I thought that we were finding percentages and that's
Oh, so you just got it backwards. So remember, this matters. We can't be certain that the percentage